I'd like to call upon Dr. V. Rajendran on the stage to start the session. So please.
Respected Chief Guest for this function, Dr. Praveen Kumar, Head International Affairs, Department of Science and Technology, New Delhi. The organizer of this conference, principal, faculty members, and delegates, and the Raman Research Foundation, uh, where it's not a welcome or it's only thanks to all of you for giving this opportunity. Even though I was given to talk on the material science domain, that is front-end area, that is newer materials, I would like to give my close to 30 plus years of experience in the field of research and development. I am up to this stage, that is the position of Vice Chancellor, only because of the reputation, the credentials which I earned because of the research and development. So in that way, I would like to first thank the convener of this conference, Dr. Sakti Pandey. He used to be one of my PhD scholars out of 32 PhDs, completed PhD. There are three more scholars yet to complete PhD under my guidance. Of course, your chief guest is also my proud alumni, one of the scholars. There are many research scholars right now here. Dr. Aravindan is here. Dr. Nisa is there. Dr. Arun Mehta is there. Dr. Swami is also there. It's a proud moment. In spite of several assignment and pre-planned, scheduled meeting, I accepted this invitation to be with this conference. Something is great if you are going to receive an award from my own scholar, Dr. Praveen Kumar. Thank you, sir. The whole SRM and Dr. Sakti Pandya and his team, Professor and Head of Physics Department, and many other faculty members. It's a proud moment for me. So that's why I'm here, and I'm not going to take much of your time. Only maybe some 10 or 15 minutes only. The second thing, when I was, I'm a person from a humble agricultural family, that too from a village, till my 12th standard. I used to study only with the Harikal lamp. In fact, I had a lot of other problems also. After plus two, I entered into the BSc stream with Tamil, but joined as English medium. Then I have completed BSc and so on. So I got the PhD from Ananda University, MPhil PhD altogether. Then I started my career in college for 15 years, and then KSR Group for 12 years, and then NGP Arts and Science College as a principal. It's about 10,000 students as a principal for 5 years, and then I joined this Amati University. It's a unique, distinct university which focus on maritime studies as a vice chancellor last March 2023. The reason why I'm telling all this information, I started on the basically I got PhD in the field of chemistry. That is taking two different liquids, mixing together what is happening, molecular interaction studies, hydrogen bond and all the things. So chemistry person doing molecular interaction study will be different. As a physics person doing the molecular interaction study will be different. If anyone, if asked them what is hydrogen bond, they will say number of electron sharing and all the things. But if you ask them in terms of physics person, they will say in terms of energy. So they approach the application of the physics people will be interdisciplinary approach is different. So the concept is, being from the agricultural family, I started working in nanotechnology in the year 1996-7 also. I started close to 97, 98 also started late evenings, late part of the 90s. I started working on the nanotechnology. Then fully I concentrated on the nanotechnology close to 2000. Then I moved from MEPCO to KSR. That time, I would like to come out with a center for nanoscience and technology. That should be a unique center across the globe, where we can get a lot of funding from different corners. See, basically, I'm an agriculture person. There are two examples I will give, and what is the outcome of that. So you also know the rice. Paddy means when you are having on the stem, leaf, and everything. You take the paddy. If you remove the paddy, the shell of the paddy, then you will get the cover outer shell, then rice. Leave alone the rice separately. Take the paddy only. That is shell only. Husk, we call husk. In those days, tea shop and all the things, now we are having on the LPG. Those days, on the hotels, they will take this rusk and put it into the fire. It will give more energy, and they will use for the producing tea, coffee, or the getting dosa, etc., etc. Then I thought burning, it will, instead of darkness, the powder, you will get the white powder in case of the husk. Then I thought of something is different. There may be a possibility we can get silica. So that explode me, take the rice husk, burn it, then we got on the nanosilica. Something different. I got the patent, still it is valid, but I'm not able to commercialize. That is different story. Then there was another idea. Is it possible to convert that silica into silicon for different energy application because of the band gap and the energy storage and all things? Then we converted into silica into silicon with high band gap energy that we are used for on the battery application, lithium battery, in collaboration with on the NTU, National Taiwan University. It's published in Chemistry Journal. I think impact factor is close to 20 plus. So what I'm trying to say, that is the outcome. Similarly, we are having a lot of from the different soils. The soil in Tanjore is different. The soil in my place is different. In Sivagasi is different. Completely fluoride. There are different soils. Then lot of sand, more than 7,500 kilometers we are having on the coastal area, seashore. Sand is different. Is there any possibility to come out with on the minerals from the natural resources? So we used box, then we used on the sand to come out with the aluminum, titanium, magnesium, many nanomaterials. That is all my projects, plus students, all except 3 persons. One is the another one is the one part-time staff. She was a professor in the college, and third is also a part-time staff. Other than that, all of them, they used to get on the stipend. For instance, my first scholar, when he was getting the 5th pay commission, I was getting on the 4th pay commission, higher than my salary is getting. So what I mean that the total period, whatever we have spent, I mean close to 12 years, I was in KSR group of institution. We have 9 different laboratories, starting from normal conventional, then AFM, XRD, everything we have established. And some of the technology we have transferred to Kalpakam also. So what I'm trying to say, the MTech program in nanoscience and technology, BTech in nanoscience and technology, we have, and the person introduced to AICT, the nomenclature and the program. So for any engineering program, we need at least 6 to 7 laboratories. All the labs we are utilizing only from the research based grant, whatever we have received. Of course, the institute has given on the matching grant. So whatever the papers we have published so far, it stands on good citation. So that's why, since from Stanford University, USA, and the LC went together, they would like to come out with on the by means of 14 different parameters, they have evaluated the best contributors, the scientists across the world. I was standing one of the two topmost scientists, 2% world scientists in that category. The special feature of this is, out of 30 PhD scholars who got graduate, PhD with me, two of them, they are also in the top 2% world scientists. One is on the Dr. Yuva Kumar and another one is on the Dr. Nagaran. Out of 30 plus PhD scholars, close to 5 members become on the family. 5 members become on the family. So still there are 2 families in here. So what I'm trying to say, there are a lot of similarly natural mineral resources also. Plant, herbal plants, lot of things we have done. I cannot explain all those things. But see, being a young mind, suppose if you are going to see this plant, why we are going to have this plant here? And they will plant on the, yesterday itself they have brought here, but by means of using some clay, they are plugging in and they are placing before. Still it is fade or go down for another 24 hours. What is the reason? Something you should discuss, something you should provocate yourself. What you call the lateral thinking, the design thinking. If you are capable of exploring, fine tuning yourself, you can come out with a lot of best ideas. Something unique, something different. One of our project, bauxite, Salem is famous for known for bauxite. We got the Nano Mission project, 1.5 crores. The initial stage when the Nano Mission was introduced, that time Dr. Praveen also in the committee. That project we did in association with Dalmia Institute of Science and Technology, which is located in Rajkampur. They are also having factory in the Dalmia factory in the nearby Salem also they are having. We come out with the technology by means of spray pyrolysis. We have converted to aluminum nanopowders, magnesium nanopowders. That company is producing insulators for high temperature application like furnace and all the things. You can go up to 1600, 2500, 3000 degree temperature, but there will be some insulation part maybe on the half feet or 2 feet. They are incorporating this nanoparticle into this material, ceramic material, and then they are improving the insulation temperature. That is converted into technology transfer. So what the industry is requiring at this stage, since I have traveled a long journey, basically, originally we work with basic research, applied research, technology-based research. That is one era, it is gone. People asked to work for the interdisciplinary, come out with application, etc. That is also gone. Now it is product-based industry, product-based on the project. Otherwise, they will not science in the project. Am I correct, sir? Absolutely, it is correct. If you are having any idea, come out with the idea, come out with the methodology, so that you can produce some product. Whatever may be the product, doesn't matter. You can have startup program, you can have number of hackathons there, institution innovation cell is there, they will provide a lot of support. So dear my students, It is a great opportunity. You may be a computer science, you may be a physics, or you may be chemistry, you may be engineering technology, doesn't matter. There is no discipline now. All are equal. Something is with you. Your identity is totally different when compared with others. What is the inherent capacity you are having inbuilt? Inherent capacity. Explore that, trigger that, utilize that, and capture that one, encash that one. So it is a great opportunity. India, lot of opportunity. So please think in that domain. So there are a lot of opportunities. Students use that. There are government funding agencies available. This DS field for your life as well as for your career applications. So I would like to finally thank each.
On behalf of the organizers, there is a small memento to the speakers.
MES-based sensor and nanostructure-based sensor in reputed journal.
She's on the way. She's on the way. Ma'am, I kindly invite you to continue the session.
Thank you. Sorry for keep you waiting. As my introduction is already over, I will be covering in my slides a brief about Anusandhan National Science Foundation, which is newly constituted as a body. So all of you are aware about Science and Engineering Research Board, and this is a new phase of SCRP only, and with lot of expectations from NRF as well as research community. We have tried our level best to incorporate all the suggestions of the scientific community while bulletin and Anusandhan Research Foundation. And I will start the origin of Anusandhan National Foundation lies from the National Education Policy which was derived in 2020 and who will implement. We thought about transforming the quality and quantity of research in our country. There was a need for implementation of these concepts. So a strategy and implementation was required. So SCRP was identified for implementation of NEP 2020 successfully. The act of NRF was notified on this year only on 5th of February. The body, the foundation will provide a high-level strategic directions in various fields of science and technology. It will also cover scientific and technological interfaces of humanity and social sciences. There will be three of these stages who will be governing Anusandhan National Foundation. First will be governing board, which will be the president of this board will be Honorable PM and the secretaries of departments and ministries will also be member of this board.
Okay.
And following this, the direction given by governing board will be considered and will be settled by Executive Council, which is being chaired by PSC to Government of India, Professor A.K. Sood. And for recommendations at project level and program level, there will be, as usual, committees and task, which may be PAC, Program Advisory Committee, Expert Committee, or Task Force Committee. And they will be taking the decisions on recommendations of proposal as well as their financial part. So these are the steps ANRF is supposed to take to lead the transformation in the country. We are supposed to involve universities and colleges in the funding as well as evaluation mechanism. There is a need to facilitate research at academic institutions, especially state universities. So some schemes will be evolved to keep that concept in mind, and some schemes will be evolved to support infrastructure development as well as capacity building. These are some categories I am sharing with you. These programs are already derived. Most of them are already derived, and to implement some of the strategic components of NRF, it first comes hub and spoke framework. There is a scheme recently launched this last month only, PAIR. In that, there is a specific category for hub and spoke. NIRF ranking is the key factor in defining hub and spoke. And this scheme is started to boost research capabilities in universities. Next comes mission. Next comes mission mode activities. We have launched in the month of October a mission on e-mobility, and the target is global competitiveness in priority areas. And definitely in Maha program, you will be seeing thematic calls only. It will be sectoral research. So next expected call will be on advanced materials probably. The Center of Excellence scheme is not yet formulated. It will be ACE, another Centers of Excellences, and it will target capacity building, and it will definitely improve global ranking of our country and by improving the status of top 100 institutions. PMECRG, the scheme call for proposal is already closed. I hope you all must have submitted, maybe some of you might have submitted your proposals. I will be briefing individually about these schemes in my further slides. To support capacity building, NRF will also be like SERB, we will be providing basic research and applied research altogether. And early career researchers will also be supported. There are specified schemes for that. In projects, till now we were supporting JRF, SRF, RA, and some other specified manpower designations. Now postdoctorals will also be supported through individual projects, which are supported through various schemes of SCRB. And ANRF will also be responsible to provide conducive platform for international collaboration. There may be fellowships, there may be research opportunities. In various aspects, we will be covering and addressing the needs of Indian researchers so that they can be getting exposure at doctoral level also. Because international exposure is common at postdoctoral level. We will keep that concept in mind and we will try to derive some programs to make them exposed to international platforms at doctoral level itself. And interdisciplinary research in social sciences and humanities through Center of Excellence will also be targeted. It will not target specifically humanities or social sciences. It will cover as I have mentioned there, the applicability of these areas in science and engineering. So it may be computational economics, digital humanities, artificial intelligence, ethics, and other sub-areas as mentioned here. And through these programs, we will also support research on public policies. It is very much required to know the exact status of R&D landscape of our country. We will also take in mind to work on ease of doing research. Through various interactions, we came to know that there are various parameters researchers are stuck on, and they used to request if we can find this flexibility, we will be able to contribute more. So, keeping that in consideration, some new points are added through ANRF that covers rationalization of funding heads, flexibility in hiring manpower, like previously it was for JRF, SRF, and RMOD. Now, flexibilities are there. There will be support for filing patents, which was not there previously. And there will be some changes in procurement conditions of pension equipments. And as usual, we were doing in SCRB also, we can assure high level of transparency, but we also expect scientific integrity and ethical conduct. A committee will also be formulated to know the to prepare annual survey of outcomes of ANRF. So that to just improve the scope for improvement, to just identify the scope of improvement and to come up and involve further programs as per the need of current state of art. Before going individually into the schemes, I will be introducing some common criteria which are the schemes which are launched yet. These some of the parameters are common for them. Maybe the schemes which are being involved, it may differ. Like for all the schemes, for PMECRG, IRG, EV Mission, and PAIR. Eligibility is Indian nationals, OCI or PIU. We have recently issued an OM to support OCI or PIU. Previously, it was for all foreign nationals. PhD degree is also required, or if PhD degree is not there, MD, MS, or MDS degree should be there. The regular position is also military, as we were also following for SCRT schemes. The travel part will include international travel also. There are some changes in overhead support. The contingency will now include publication charges and patent filing expenses also. The call for proposal for all the schemes will only be notified through ANRF online or ANRF Gov. While as we were doing for SCRT, now sir, all the PIs, then profile section is there. Please be careful while you are selecting the profile. If the person is, if the researcher is contributing as PI or co-PI, please mention that clearly, right, while submitting. And there are some key elements, as we all are aware. I'm not supposed to explain that, and some supporting documents. It was already there. Now comes specifically for PMECRG. There is a one-time relaxation this time. That, for in SCRB, it was the age limit was 42 years, sorry, at the time of submission of the proposal. Now it is 1st February 2024 because we couldn't announce the call under this scheme for a year. And the date of joining is also expected to be. There is a relaxation of 8 to 9 months in this also. The eligibility is same as we were doing in SCRB. It should be, PI should come up with a proposal within 2 years of his joining in the institute. After age limit 42, there is a relaxation for particular categories, and it is also the same. The grant of 60 lakh will be provided for 3 years, which exposed overhead. This is the first mission launched under MAHA program, that is Mission for Advancement in High Impact Areas. And there are 3 technology verticals which are defined to accept the proposals in this particular mission. However, we are not very specific. If you are having any other component which is not covered in the call, you may come up with that, especially in EV battery vertical. The structure, it's not like it's not a PI co-PI like we were doing for other schemes of ANRF. There is a concept of inode. We expect collaborative approach. Lead PI should be from an academic institution, and other PIs can, the same approach is being used. If a person is if a PI is going to be superannuated, he must be having at least 4 years of service remaining to come up with project under this scheme. If a researcher is having an ongoing project, maybe as PI or co-PI in EMAQ, they are not eligible to apply in IRG. Like we were doing for EMAQ, the same condition applies here also. IRG, in your tenure, you can get maximum 3 IRG supports. The funding component is same as PMECRG. I will conclude here. Thank you very much.
Thank you, ma'am, for sharing your knowledge with us.
Is there any scheme for retiring? I am now in my retirement. Within 3 months, I am going to retire. I already got one project in 2019.
The canteen is free now.
This is email from you in 2019. I got this project and lost I completed successfully and I got excellent star.
I understand, sir. There was a scheme in SC Aviation Science Chair for scientists who was superannuated with excellent track record, and hopefully we will come up with a new concept.
You was the in charge.
Yes, sir.
Thank you, Dr. of your things. So first of all, I would like to thank. I'm a user of NPDF completed. Now TARL projects I go to something. So thanks to SCRP as well as now.
Yes, sir.
My common question is thereafter in the mission project kind of things.
Getting late.
It should be like major concepts.
Maybe you can come up with new concept also. It was specifically for EV. So maybe when we are getting involved in other things, we can change that concept. I cannot. We can change it. Because in all the areas, industry partnership will not be possible. So, because of that constraint, we can come up with new concepts.
Some materials or advanced
And
materials.
the startups and industries are not working in all the areas.
Yeah.
So that may be the limitation. We can come up with new concepts.
And the remaining things of the SCRB can be converted like TARA or NPDF.
TAR is already there. PR is already there. So, yeah, CRG, maybe we are restructuring them. You are more nervous when your senior is there. You cannot commit. You cannot assure anything. But definitely within a month, we are going to announce ARG. That will be restructuring of CRG, Core Research and Advanced Research. I am also learning for the first time. So actually, we gave sufficient time. It was announced on 14th October. So extended also by at least about 9-10 working days. I don't think it will be possible. If there is anything update. And Mr. Only can use such plan. Okay, restructuring of SRD research. PM professorship. And PM, they call for proposal in IRG and PAIR are already ordered. PAIR is still 15th January. IRG, I guess, 15th December. So advanced materials call me. Yeah, they cannot be. Yeah, definitely. That OM is there. Yes, people such will find that OM. It was issued on 1st October this year. Any further question? Thank you very much.
Thank you.
Thank you, ma'am, for sharing your knowledge. Now, let us welcome Dr. S. a renowned professor from the National Institute of Technology, Bangalore. Dr. Anandan's expertise has been shaping the minds of future engineers and innovators. We are honored to call upon Dr. Anandan to share a few words with us. So please.
Hello. Good afternoon, everyone. So it's my pleasure to stand before you to deliver my annual lecture, which will be on an overview of polymeric nanofabrics as gel polymer electrolytes in secondary batteries. So I am from the Department of Metallurgical and Materials Engineering of the National Institute of Technology, Karnataka, Surat. First of all, I would like to thank Dr. Sakti Pandey and his team for extending an invitation to me to deliver this talk here. So it's my real pleasure to share some of the results of my team with you all. As you all know, my institute is National Institute of Technology, Karnataka, which is an institute of national importance, and it is spread over an area of 300 acres, including private beach. And we have 30 academic departments and a school and a central research facility that was established in the year 2020. We have UG and PG programs in all the departments and also doctoral program as well as postdoctoral fellowship. We have currently around 300 faculty members and 7,000 students. And this is my department, which is the Metallurgical and Materials Engineering Department. We have people with diverse research backgrounds as well as academic backgrounds. So we work in various frontier areas of metallurgy and materials engineering, such as physical metallurgy, mechanical metallurgy, ceramics, polymers, nanomaterials, corrosion, and so on. And hailing from the background of chemistry and polymer technology, I am fascinated to work with polymeric materials and nano ceramics. So let's right away get into the technical stuff. As you all know, the storage batteries are very important in a number of gadgets, including laptops, phones, etc. And we know about lithium-ion battery. We are also having sodium-ion batteries, which are upcoming, and we have also worked with magnesium-ion batteries. Sodium-ion batteries started emerging in the academic and research field since 2010, and it is largely due to the uneven geographic distribution and high environmental impact, as well as high cost of lithium. And the sources of lithium are also fast depleting, and lithium salts, which are used as electrolytes, and lithium metal that is used in developing lithium-ion batteries, pose a large number of problems, because you might have seen some cheap quality batteries exploding and causing a lot of accidents. And there is a phenomenon called thermal runaway, which is because of the very poor heat dissipation from the stack of several lithium ion cells, which we call as a lithium ion battery. So several cells stacked together is a battery, and thermal runaway is a problem caused by poor thermal management in the lithium ion batteries, which is also really a big challenge. And also, along with that, dendritic growth in the electrode punctures the separator in the battery. I will come in a while into what is meant by a separator. So, in short, I can tell you that lithium-ion batteries, working and developing the lithium-ion batteries itself is a really big challenge. So, the interest has shifted to sodium-ion and other ion-based batteries because sodium is highly abundant, particularly in seawater, and in any cell, which we colloquially call as a battery. By right, you should call cell, electrochemical cell, which has three components, namely anode, cathode, and a separator. I have worked elaborately on separators. That's why I have highlighted the word separator. It is an inseparable and inevitable component in any battery, which separates anode from the cathode, and it allows the passage of only ions across it. And the movement of ions holds the key for the power generation. So, during charging, movement of ions will be in one direction. During discharging or drawing of power from the cell or battery, the movement will be in the opposite direction. Both these movements are really important for the charging characteristics of any electrochemical cell. So, why we work on separators? I am a polymer specialist, so I am always fascinated to work with anything that is made of a polymeric material, be it a polymer blend or a polymer composite. To be very specific, we worked on polymer nanocomposites. So I am fascinated to developing the separators with improved characteristics. So separators which are currently in use may have certain drawbacks such as mechanical failure, dimensional instability, and narrow use temperature, short lifespan, and sometimes it may also lead to explosions because you can see here the schematic animation showing the movement of ions during the charging and discharging cycles of typical sodium. In the left hand side, you are seeing the schematic exploded view of the cell, electrochemical cell, where you are seeing the anode and the cathode, which are separated by porous separator. So, what are the ideal characteristics that a separator should possess? Lower crystallinity, higher electrochemical stability, high ionic conductivity, and high specific surface area and porosity, which will facilitate the movement of ions across. And we have different types of sodium-ion battery chemistries. They are developed from various electrode materials as well as separators, but the commercially available batteries invariably have a separator made of polyolefin polymers. Polyolefin means it is getting too technical, so to put in a very simple language, polyethylene, polypropylene, that is called polyolefin. Olefin is alkene, unsaturated monomer. When you polymerize it, it becomes saturated in terms of the backbone structure. Okay, so we call them polyolefins. They have low thermal stability. They can melt at lower temperatures. When you are using a battery, when you are drawing power from a battery, you would have observed that it is getting heated up. So this heat, when not controlled sometimes, may melt down the separator, which will lead to abrupt mixing of the components from the cathodic and anodic compartments. That will lead to explosions, or the battery will die. So these are some of the issues with the polyolefin-based separators. So with that in mind, we wanted to replace the polyolefin separator from the lithium-ion and the sodium-ion batteries. So we chose a fluoropolymer, which is called polyvinylidene fluoride. That polymer is also known for its multiferroic nature or electroactive character. So that we chose because of its inherent flame retardant nature. Even in case of fire, it will withstand the fire and it will resist the flame. It will oppose the flame, so it won't burn. So we try to develop separators for lithium-ion and sodium-ion batteries. Due to the problems which I addressed just now, we wanted to replace the existing commercially available separators from the lithium-ion and sodium-ion batteries. So we chose the polyvinylidene chloride for our work. I will just skip some of the slides because of the time restrictions, but I will try to put everything together as I talk. So these are the essential characteristics expected from a separator. Chemical stability, fine thickness. Thickness of a typical separator is 24 micrometer. That's why you will see in all the commercial separator names, they'll be using the two numbers, two numerals, 2, 4. Any battery name, any separator name will start with the 2 digits, 2, 4, followed by some secret names, which may indicate something. Okay, so 2400. That is the actual terminology used in commercial separators. Here you can see a tri-layer polyolefin based separator. On top and bottom you are seeing the polyolefin component, and in the middle we have polyethylene component. So it's a commercial tri-layer separator. So we wanted to improve the porosity of the separator, because without a substantial amount of porosity, ion movement is restricted. If ion movement is restricted, charging and discharging characteristics are going to be limited. So porosity is one of the key problems that we address. Along with that, wettability is very poor for polyolefin separators because they are like wax, right? Hydrocarbons, right? So any liquid that is used as electrolyte, you will find it hard to wet the surface of this separator, and automatically performance will be very much limited because of this wettability issue. So why we have chosen fluoropolymer? Carbon fluorine bond is polar, so that may be easily wetted by the electrolyte, which is an ionic compound, like for example sodium perchlorate or lithium hexafluorophosphate, LiPF6. So these ionic electrolytes can easily wet the surface of a polar polymer, right? So porosity, how we introduce into the separator, that is a very important problem. You may prepare a film from any polymer that will have very less porosity. You may prepare a film by casting or hot pressing. That membrane or separator will have very low porosity. And if you select the process called electrospinning, which is the process of making nanoscale fibers using electrostatic charges, right? That will lead to the formation of nanofibers, and many such nanofibers can be developed by the process called electrospinning. So that process will give you a fabric like this. The schematic of the fabric is shown here. In the middle, you are seeing the non-woven fabric, because we don't subject the nanofibers to a process called weaving. So they naturally get randomly deposited during the electrospinning process. So that gives rise to the 24 micrometer thick separator. That will have very high porosity because of the randomness of the fibers. In between fibers, you have a lot of pores, lot of space. So that will lead to an increase in the porosity. Not only that, due to the fineness of the size of the nanofibers, the surface area will be tremendously improved. So these factors will play a very key role in improving the wettability of the separator. So ion movement will be facilitated. So wettability improvement, facilitating the ion movement, enhancing the safety of the battery. All these things we can achieve if you select the polymer, fluoropolymer, and you make the separator by the process called electrospinning. So these are some of the advantages, and these things are all available in review papers as well as standard books. So I'm not going to waste your time as well as mine. So I'll just quickly move through these slides. So this is the basic of the electrospinning process, where the polymer droplet is made to acquire electrostatic charges. The moment electrostatic charges quantity is beyond a certain cutoff value, they will discharge this droplet, right? Why a free falling droplet is always spherical in shape? Because of the forces of surface tension or holding it in the shape of near spherical. So when electrostatic forces are accumulating on the spherical droplet, at a certain point, they will overcome the surface tension forces and it will be drawn. The droplet will be drawn, and if the voltage is still increased higher, there will be fiber formation because the jet that forms will move very fast towards the grounded collector plate. As you can see here in the two videos, fibers are developing. Can you see that? Fiber jet is moving. So this is nothing but the jet. After it loses its solvent, it is going to be deposited on the collector or target in the form of a nanofiber mat or a non-woven fabric. So we use the rotating drum. Here in the schematic, what you see here is a metallic plate, static plate. When you use a high-speed metallic drum, that will orient or align the fibers. That is very crucial for certain applications, like the energy harvesting applications, where I also work. So this is energy storage application. So the nanofibers or nanofabrics find applications in number of areas like environmental, electronic, consumer products, healthcare, and energy harvesting as well as the storage. So I am now talking about the applications of the nanofibers in energy storage, namely the development of separator for batteries. So nanofibers are always important. It is not just a research material, but it is also very important in day-to-day applications as well as in industries. You can see that the growth of this nanofiber market is always exponentially growing. Okay, this is the data from the US. You can see the data, worldwide data also. It is available in the web. So you will be astonished to see that nanofiber market is always in demand. And even during the COVID, we had to use personal protective equipment, which is based on nanofabrics, melt blown, melt spun. They call it melt spun or melt blown fibers, which was used in developing masks, N95 masks and all, right? So we needed nanofibers and nanofabrics. So that summarizes the importance of nanofabrics. So can we do it industrially? Why not? This process is highly scalable. Instead of doing it using a spinneret or a syringe, you just switch over to a trough where you keep a large volume of the polymer dissolved in a suitable solvent. Then you subject that to a process where a mandrel with several wires is rotating inside that solution. And this mandrel is connected to a high voltage DC power supply. So each wire, when it touches the polymer solution, will pick up a number of droplets. And in turn, these droplets will acquire the electrostatic charges because the mandrel is connected to the positive terminal of the power supply. So once the cutoff voltage is exceeded, fiber jets will start moving towards the top collector plate. So industrially, this process is able to produce a large volume of the nanofabric in a short span of time. This equipment is really expensive. So currently in India, I think only IIT Madras is having in Professor Pradeep's group. We haven't tried to use that equipment, but still we are happy with whatever equipment we are having in our lab, where we can fit 10 syringes at a time and spin. So in this part of the work, we wanted to improvise the properties of the polymer PVDF, polyvinylidene fluoride, further by incorporating some nanotubes, which is a naturally occurring monomerlinite based clay based tube. It is exactly not like CNT. It is just a sheet of clay rolled. The two ends are still open. So it's a very unique structure that you can easily model by rolling a sheet of paper without connecting the ends. So that is how the halosite forms. I have shown the structure here. It is actually aluminosilicate based clay. The idea of choosing this nanotube for adding to the PVDF is that it has highly active surface groups which can attract the hydrogen atoms from the polymer chain. PVDF is having a very simple repeating unit, CH2, CF2. CH2, CF2. Polyethylene is CH2, CH2. All CH2, CH2. So it's a hydrocarbon. Here it's a fluorocarbon plastic. You know Teflon? CF2, CF2. No hydrogens at all. So it is in between. CH2, CF2. So the hydrogen atoms are selectively going to be attracted to the surface of the halosite nanotube. That will align the polymer chains in a particular fashion, which the chemists know as the conformation. What is the conformation? A conformation is a structure in an organic molecule which is obtained by rotating the structure around carbon-carbon single bonds without breaking the bonds. That is conformation. So, and in a particular conformation, this polymer will have, okay, it is not there, it may be in the back. It is there, I will just show you what is. Okay, anyway, never mind. Let me tell you, this polymer CH2CF2 with the repeating unit CH2CF2 can exist in 5 different polymorphic cases, starting from alpha, ending with epsilon. So alpha, beta, gamma, delta, and epsilon, among which only the beta and gamma phases are known for their electroactive character, because the conformation is such that the dipole moment of the structure is non-zero with a decent positive value. So that leads to the electroactive character of this polymer. So our objective was to improve the electroactive character of this polymer, while it is also in the form of a nanofiber and nanofabric. Right? It is also associated with the inorganic nanotube, halosite nanotube. That will further enhance the flame retardance of this polymer. This polymer is already flame retardant, but this will also, the interaction of this polymer with the halosite nanotube will also enhance the mechanical property, which will add up to the tensile strength as well as puncture strength. Because in lithium-ion batteries, the dendritic formation in the electrodes will puncture the separator, right? So that is a very, what I can say, very soft component in the battery. So that can easily be punctured. So puncture strength is also to be improved for this separator. So when we incorporate the halosite nanotube, the tensile strength as well as the puncture strength are improved. So that will really be very good for the performance of the battery. So we have to evaluate the battery performance. We have developed the membrane from the combination of the polymer and the halosite nanotube. We have also converted the mixture into nanofabric with good porosity, with good wettability. Fine. You have to assess the performance of the battery, which we prepare with this membrane, which also was done by our group. So I will be just showing the results quickly. So we optimize the process for electro spinning, and thereby we develop the nanofabric with this spinning protocol. This is the equipment that we have. This is having a higher production capacity. We had, I had produced around so far 8 PhDs with a single spinneret electro spinning equipment. This equipment has the facility to include 10 spinnerets at a time. So the productivity is 10 times higher. But still, I am yet to produce a PhD from this machine. I worked all the way with a single spinneret equipment, which requires a lot of patience from the student side. So 5 ml, if you want to convert into a fabric, the flow rate will be 0.5 ml per hour or 1 ml per hour. So imagine how long it will take for developing a decent sized nano fabric. So patience is the key, along with intelligence. So we assess all the properties like the morphology, wettability, porosity of these separator, and we have also seen how the hallocyte nanotube is distributed or disposed inside the polymer matrix. And we have also assessed the phases that are produced in this polymer composite membrane. And we have tested the mechanical properties, which is really very important, as I have told you before. So the tensile strength is really very high, as per the standard set by the United States Advanced Battery Consortium. They specify a certain value of tensile strength and puncture strength, right? Unless your new separator falls into the values, meets the requirements, you cannot use for battery development. So we developed this separator with the required US ABC specified mechanical property values. So here the actual values are given. And wettability also we assess by contact angle measurement, which is a very straightforward measurement. The smaller the value of contact angle, the better the wettability, right? And we have assessed the porosity by the standard procedure. We found that the nano composite based fabric has the highest porosity, which is also going to be very beneficial for the battery's performance. We assess the wettability, right? So the electrolyte is also really very high for this, compared with the standard cell guard separator, which is a polyolefin based one. Here we have used our fluorocarbon based one in the form of a nanocomposite. So the uptake is several times higher, 8 times, almost 8 times. And we have also subjected this electrospun nanofabric to thermal shrinkage test, which we designed in our lab. This procedure we developed, and we found that there is no appreciable shrinkage in our newly developed separator. So that also will confirm the thermal stability of your battery. And these are the electrochemical studies. We have done linear sweep polarimetry and DC polarization studies. From this, we will get the transport number value. If the transport number value is close to 1, that means the ion transport is really very good across your separator. And here you can see the commercial separator has a transport number of only 0.33, whereas the newly developed one has 0.64. So transport is really very good. The ion transport is really very good. We have also studied the AC ionic conductivity and other factors also we have studied, which are key for the performance of the battery. And we assembled finally a battery. This is the real life experiment. So we developed a coin cell in our collaborators facility at IIT Kharagpur. They have the so-called dry room. Dry room means 0% humidity. It's really a big challenge to stand and work there. Only that facility they have, and people are normally using glove box. And this is no glove box. A full room, full lab itself is modified into a dry room, where they have done all these battery related things. And finally, we evaluated the characteristics like energy density, specific capacity, and so on. Here you can see the charge discharge experiments done over 100 cycles, and we found that the charge retention, the capability of charge retention, which is measured as Coulombic efficiency, is about 98.5%. There is minimal loss in the performance. So, what is the typical lifespan of your mobile phone? It is decided by the lifespan of your battery, correct? So, we have to improve the lifespan of your battery. That is the key here. So, this experiment is really inevitable. This is the proving ground. Without this experiment, your battery will not be accepted. So, in another part of the work, we have done the development of similar electrospun nanofabric from the same polymer but a different filler. We used a different inorganic nanofiller, which is a layered double hydroxide, LDH. The ions we can vary, but here we have purposely selected calcium and aluminum because of their high thermal stability, so that this, when included into the separator, will improve the thermal stability further. So that was the idea. In the first part of the work, I had shown you nanotube. Here I am going to show you nano layer. You know the reason? Why no nanoparticle? Why only layer and just like graphene, this is a nano sheet or nano layer. Just like CNT, the previous one was a nanotube. But there is no spherical nanoparticle in our world. Why? Anybody knows the reason? The aspect ratio and surface area per given volume are very high for these two geometries only, the cylindrical geometry as well as layer geometry. That is the very important reason one should know. So that's why we selected this LDH, and we synthesized this LDH in our lab. For the first ever time, we synthesized this composition. I'm not telling that this material was first ever synthesized in our lab. This material with this composition, by this particular method, we reported for the first ever time. The method is called co-precipitation method. So this particular composition we developed and we characterize it. You can see the nano layer structure there. The nano layer structure you can see there, which looks like graphene plates. So this we incorporated into the polymer solution, and we have developed the nano fabrics. So just like the previous one, we have studied the various physicochemical characteristics that are required to understand the material's behavior. So we have done all that morphology study and texture studies and porosity measurement, along with the wettability study, and finally the electrochemical performance study. So the transport number was also very high here, 0.98. In the previous case, which I showed, 0.64. That was the T plus value. Here it is close to 1. So it's really very good for the battery's performance. And we have also done the measurement of the mechanical properties as well as the thermal shrinkage study. This is the last and final part of the study where we have studied the charge discharge behavior of the battery that is assembled with our newly developed separator in the coil cell. So this is the separator. You can see how thin it can be, just 24 micrometer thickness. Yeah, this is the whole setup. So these are the curves which will show you the various electrochemical parameters like specific capacity, charge and discharge capacity. So here also we found that the capacity, charge retention capacity was almost about 100%. Performance was really very good. So we conclude that this strategy can be very well used, and who knows, you can modify this procedure also. And in some of our other works which I have shown here, we have done something new. We have tried something new where the commercially available cell guard membrane we took. On top of that, we have done the electrospinning with our PVDF, and we saw how it improved the wettability, because non-polar coated with the polar polymer definitely will attract the electrolyte. So that we tried and it really works. So our idea clicked and we published it during the lockdown time in a very popular journal of Power Sources. And we have also developed a high stable, thermally stable separator for new magnesium ion battery from a polymer called polyacrylonitrile. How many of you are aware of the use of polyacrylonitrile? Industrially, it is used in large quantity. You know its importance? Sorry? Not at all. That is polycarbonate. Polyacrylonitrile is the precursor for carbon fibers, period. I don't have to tell you anything further about carbon fibers. So such a polymer with very good properties. So this is the final food for thought. Since I spoke about energy and battery, let us see what our heart does every day. Every day, our heart creates enough energy to drive a truck for 20 miles. So from Trichy to easily nearby places, you can reach with this much of energy. So be energetic always. That is the final take-home message. So I would like to thank once again Professor Satyapali for inviting me here to share my results with you all. So thanks for being a wonderful audience. Thank you very much. And this is, I just want to show you last week's simulation. This simulation showed structures which very much resembled that of the nano fabric. Man-made, and that one is natural. I thank my student, the former student, Dr. Sachin Kumar, who is currently placed in Avient Corporation in Pune, which is a company known for making the bulletproof jackets from ultra-high molecular weight polyethylene. So he is currently working there. He is the one who developed this slide, this particular one. So I also want to thank all my students who have done the work on batteries. So we have more than 10 on various batteries, lithium-ion, sodium-ion, and magnesium-ion batteries, in collaboration with our wonderful friend from IIT Kharagpur, Professor Veni Madhav. So with that, I would like to conclude, and thank you very much. I hope I have completed in this time.
Excellent presentation, sir. Thank you, sir. Basically, is there any significance in the Simco micromobility?
Yeah, actually, that is the specification as determined by the Battery Association of USA, because that is found to have optimal performance from various points of view. It is not just the ease of production of the separator, but battery's performance, battery safety, all these things are taken into consideration. So, with that, they have decided it should be around 24 microns.
Selling by custom, it is very tough to maintain such
We can control. Yeah, we do control actually. We know the strategy. Thermal runaway and aging problem, physical aging, because of lot of chemistry is involved, right? Lot of thermal history is also involved, right? All these things definitely spoil the materials inside. So battery becomes useless after a certain number of charge discharges. That's why I said in the beginning itself, the life of the battery decides the life of your mobile phone. So you want to replace your battery, the company guy, the shop guy will make you feel like, why should I replace? Let me buy a new phone. They will make you feel that way. Thank you.
So here they are using only for polyolefins. They are using any different.
No. They are commercially invariably they are using only the polyolefin separators, and they have made it into a smart membrane, which I forgot to mention. There is a single layer separator which is for cheap batteries. There is a tri-layer battery. I had shown you. On either side we have polypropylene. In the middle we have polyethylene. In case of a thermal runaway, it will melt. The polyethylene in the middle will melt and close down the ports. So any more movement will be completely stopped. So no further ion movement, no drawing of power from the battery. It will shut off the ports. So that is the mechanism by which the tri-layer separator works. For the melting point, I'm sorry to interrupt. Melting point of polypropylene is around 170 degrees Celsius. Whereas for polyethylene, depending upon whether it is LDPE or HDPE, it may be either 140 degrees. So there is a subtle difference between the melting points of these two polymers.
So the second part you told about the metal is going to be insulated.
No metal, no.
Nanometer. Aluminum.
No, they double hydroxide. The structure. Yeah, you write it here. Yeah, it is here. Schematic, how it forms. Hydroxide will be there. Aluminum, they will assemble in a particular fashion. And in between successive layers, we have some replaceable ions. Definitely it will be. So, if you know some colloid science, I would say that you go for some zeta potential measurements. That will also give you the answer whether this material is suitable or not.
Thank you, sir, for sharing such inspiring words. It will be very useful for research scholars and future scientists. Now, I would like to call upon Dr. K. Sakti Pandey to present a small memento to Dr. S. Anandan. It is time to take a pause from enjoy some well-deserved refreshment. Please make your way for lunch to the canteen. I also request everyone to arrive at 2:30 p.m. back at the same exact seminar hall. The canteen is present at the ground floor.
The lunch is arranged in the canteen. You can take your lunch and return by. The lunch is arranged in the canteen. You can take the lunch. Lunch is in the ground floor. You can take the lunch and return by.
அவ்வளோதான்.